We didn't even do anything yet. OK, thanks for having us.
Yeah, and thank you. And
I guess it's the first thing we have to do is start with an apology, because obviously the title is wrong.
Yeah, German guys not being able to spell English words properly. Sorry for that. So here we go.
Better. OK, so quick introduction. Probably makes sense. So I'm just going to give a start. So my name is Arne Blankerts. I'm part of a consulting company running around the world, trying to help teams make better software, make sustainable and maintainable software, and of course also deal with production issues, all kinds of things that are potentially important to keep PHP alive and keep your PHP application alive.
Yeah, and hi, I'm Sebastian. I work for a company that I won't mention because you wouldn't have heard of it. It's only present in the mostly German-speaking market. But I've been working with PHP for, I don't know, 16, 17 years now, probably. I've been working with Arne a lot. And, well, my company is a customer of their company. So that's why we always talk about the same topics and also do talks together about things that we work together on or that, well, cover us both. So today, that topic is PHP-FPM. And in the past, and also just yesterday, when talking to people about, yeah, this is what we're going to cover, well, we hear things like these. I don't think I've ever touched the default configuration of PHP-FPM. That's what I heard yesterday. And that's not necessarily a bad thing, because the default configuration will cover a lot of cases, so you don't always have to look at that. But sooner or later, if your application is successful and under load, you might encounter warnings like these in your error log.
Yeah, that's a good pointer that what worked for quite a while, and obviously the defaults were relatively sane because it worked for quite a while, and having 50 children running, as in things being busy, means that you're doing pretty good, and it got you quite far, but maybe not far enough, at least for now. So this standard rule, particularly on some types of closing, like one size fits all, maybe is not necessarily true anymore. So one size does not fit all. So maybe it's time to analyze what we actually been doing and how we can optimize things and what we need to change. We're going to show quite some benchmarks in between and some results, how certain changes affected certain performance criteria. And as with always with benchmarks, your mileage may vary. So depending on your application, we even have 2 different applications at some point to show that the results may look different. And some things may have a quite big impact on your environment or none at all, or maybe even negative, depending on all the requirements and what your actual application is doing. Obviously, running a faster CPU might be really cool, because logically it might be faster in running PHP code. But if your application is 90% of the time busy waiting for I/O, it's not going to help you. It's just going to wait faster. So.
Yeah, so the first thing we can and need to do is really look at the status quo. So what do I have right now? And well, one of the sources for that is the mentioned FPM error log, which probably already contains this kind of warning that you have reached a certain limit. There may be other warnings like this one. And we'll get to that in a bit, what exactly that means and why that happens and what we can do to prevent that. A second source that's quite valuable is the FPM status page that comes with PHP-FPM. So you basically just have to set that up.
Yeah, for whatever reason, it's disabled by default.
Yeah. So this would be a simple example on how to configure it. You basically first go to your FPM pool configuration, and we will talk about that in a bit as well, and enable the status path. And then also in your web server, you can configure a specific location, which then will give you something like this.
Yeah. It's vital to make sure that not everybody has access to it, because it's, well, production data. So it's very good for monitoring, because you can get it not in just plain text formats, but also in other formats. But making sure that you're the only one actually being able to see it and not the whole world might be quite a good idea.
Yeah. So this is the basic version, the basic output you get. So basically telling you facts about the overall master process and everything it handled. There's also the full parameter that you can pass on to it. Then you will get additional information for each of the worker processes. And to incorporate that into monitoring, for example, there's also something like the JSON output, so you can grab that data on a regular basis and just check if everything's all right, set up alarms if certain limits were reached. And in this output, we actually have such a situation. We have the max children reached that happened once since the master process was started. And this is exactly what the initial warning we showed was about. And that is definitely something that you would want to, well, not to happen, actually.
Yeah, that basically means that you're more successful and have more load on the systems than your systems currently are capable of handling. And we probably have to do something about it. But let's first understand how this stuff actually works. What does FPM actually do?
Yeah, so FPM has the master process, which basically just manages incoming requests. And you have worker processes, which are managed by that master process and also spawned by them, by it. And every time a request comes in, it's getting handed over to one of the workers. And the worker then is busy for a while with, well, dealing with that request. So when there are more requests coming in, while that one is busy, the next worker gets a request and so forth. And at some point, maybe all your running workers are occupied with requests, so the master process cannot hand over the next request, so it kind of has to wait for something to get free again. And that's what this warning is about.
Which may not necessarily seem like a problem at first glance, but it means that, well, things have to wait, so users have to wait. Or if it's not reached the actual max limit, but just like the amount of running processes, it has to spawn a new process, which of course will also take time. So at least that particular process will take longer, or that request for that matter, will take longer to get answered.
Yeah. So apparently, we need more workers in this scenario when this limit is reached. And there's now several, well, valid ways of configuring PHP-FPM to get that. And we'll first have a look at 3 different management modes that PHP-FPM has, which are dynamic, on-demand, and static. And dynamic is pretty much what you get as a default configuration. So,
and the funny thing is that the values that you can see in this configuration differ per distribution. So whatever kind of Linux distribution or operating system you use, those settings may be completely different. But they all have one thing in common. They are optimized for stuff that you do on your development machine, where you definitely do not want to have like 100 processes idling around. But maybe that's not optimal for production.
Yeah. And this particular piece of configuration is what you get when you install PHP 7.2 on an Ubuntu 18.04 LTS, for example. This is what you'll have as a default. And it basically says, as you can see here, we have a maximum of 5 children. Which is not too much, right? And we saw on an RPM-based distribution, we had like 50 children already configured,
yep.
Which would
as a max, not like a start service, right?
Yeah. And also dynamic as the mode means that it will not immediately create 5 workers and then keep them ready, but instead it will, in the beginning, start 2 workers and then scale up to a maximum of 5.
And it will, of course, scale down back to, in this case, 1. So which means if you start the FPM stack, it will start immediately 2, because that's what it said with start service, and just kill 1 right after, which is not really helpful.
Yeah, it's kind of a weird setting. Then there's the on-demand mode, which is quite similar to dynamic. We have a bit less of parameters here. So we again have a maximum of 5 children, and we start with 2 servers. But we don't have this min and max spare server setting. Instead, there's a timeout. So the master process will spawn new workers when there's the need for it. And if those spawned workers don't have anything to do for more than 10 seconds, then they will be removed again. So kind of the same situation. In both cases, there's like a bit of overhead because processes need to be spawned and removed again. But either way, with this kind of configuration, we use the 16-core machine, which we also use for some of the benchmarks. With this setting, you will not be able to really use the resources you have available there.
Which may be by design, but if you actually try to scale on performance for production, that might be either an oversized system, so you would scale down to a smaller box, or actually change the configuration to actually make use of the hardware you have.
Yeah. And the third mode that PHP-FPM offers is the static mode, which is actually the one that we would recommend for production. Static really means when the master process is created, it spawns as many workers as we have configured, and in this case, it's 25. And then they will just sit there and wait for something to do. So this removes this overhead of spawning new processes on demand when actually requests come in. They are just sitting there and are ready as soon as something needs to be done.
Yep. That, of course, means that those processes will stay there and be idle. So if you don't actually have the load to actually make them all busy, well, then they're just going to stay there and don't do anything. So you should also make sure, which we're going to cover a bit later, that you actually have an optimized environment, because if you have so many processes running in parallel that contain all kinds of things that you don't actually even need, then you're just wasting memory.
Yeah. And one additional setting that, depending on the application, could be interesting is this max request setting. That basically says right now, after 500 requests, a worker will be restarted. And I mean, that came from a time when PHP had a lot of memory leaks and long-running processes would just gather more and more memory, and the only way of freeing that would be to restart the process. Now with PHP 7, that got a lot better. Yeah, but still there could be applications that cause memory leaks. So ideally, you wouldn't have the need to set this. Yeah, many people still do, just in case.
Yeah, and again, depending on the distribution, this is either enabled and set to this value, or it's not used at all. That means it's the default is 0, so it's not going to actually have a max request value set.
Yeah. So now we have 25 workers configured. And, on our test machine, that already used the resources a lot more, but still there's more room for improvement. So now you can continuously increase the number, play around with it, and find like the sweet spot. Of course, this kind of requires the server to be used exclusively for FPM, right? If you have other services running on that, then, well, they need to share resources, so it's a bit harder to find the right amount of workers that you can use.
We already learned in the first session this morning that you shouldn't do that anyway.
Yeah, it's always a bad idea anyway, sure. And I mean, then of course there's also memory consumption, right? So how much memory does a request really need? So how many workers could you have in parallel without running out of memory? So there's a lot of to consider. But eventually, it will definitely help you a lot. And this is one of the benchmarks we did. This is one that you can actually just do by yourself because everything's like publicly available. So we used AWS to spin up a certain instance, used an Ubuntu image. We took a Symfony demo application, which is like a blog kind of application as a reference, and then used AB to just shoot requests at it and, well, see how much we get out per second. And the first one is the default configuration with those 5 dynamic workers running. And yeah, we certainly hit a limit there, which the resources or the hardware couldn't compensate. And for us, 50 children was quite a good number with this machine. So there we got like the maximum out of it.
If you add more children, it's actually not getting better.
Yeah.
So that's the sweet point that he just mentioned.
So with this kind of benchmark, we actually didn't reach the 50 children. We ended up at like 47, 48 max used. Yeah. But this is something that is quite easy to achieve and to look at. So this is kind of the easiest performance gain you can get out of PHP-FPM, but just looking at that. But there's a lot more to it that you can do. Some of them are really small optimizations, but some of them can also have a greater impact.
The biggest impact in total, of course, is if you have many requests and, of course, all these things and to sum up and like actually make a big impact. So even it may not necessarily make much of a difference for a single request. If you have a lot of requests and everything saves a tiny margin, then of course this margin will get bigger and bigger over time. So in the overall, you're going to save a lot.
Yeah.
That reminds me that like back, I don't know how many years ago when Facebook mentioned that they were doing this hip-hop HHVM kind of thing, they said like, okay, for the majority of PHP scripts, it doesn't really change performance too much because we're actually waiting on I/O a lot. But even if we save 1% of CPU on all the requests in total, we can shut down a bunch of servers, like hundreds of servers. So that makes quite a difference if you're that big. If you're not, well, maybe then you just don't care. But in total, if you see how much you can save on tiny things, and we're going to add more tiny things in the talk right now, this will make quite an impact in total. And we're going to see some very interesting numbers in a bit.
Yeah. So the first smaller thing you can look at is how your logging is set up for FPM. So PHP-FPM has an access log. Most of the times it's disabled by default, and that's kind of a good thing because normally you have these kinds of logs on the web server level already. So maybe the FPM access log will not give you any additional information, so you might as well switch it off.
Might be practical because you have a lot of flags that you can set what you want to have in the log format, so what information is supposed to be logged. So it might be practical after all, but keep in mind every I/O is expensive. So if you add logging, PHP-FPM has to write stuff somewhere, so that will take time.
Yeah. And the next topic is, well, related to FPM. It's not strictly like optimizing PHP-FPM itself, but it's optimizing the op cache, which is enabled by default if you use PHP-FPM.
Well, in PHP 7. Yeah. It's not necessarily true for other versions that may not exist anymore.
So, op cache. First of all, we have the status page in FPM, which is kind of integrated. You have it out of the box. For op cache, there are projects that allow you to inspect the status of your op cache. This is one of them. There's another one, which they basically do the same thing, showing data a bit differently. But what they will tell you is how much of your op cache is actually used, so how much memory is still free for that, how many files you have cached, how many hits you have. This can be really valuable information if you want to tune it, and there's a lot of potential in doing that.
Yeah. Again, the default settings make a lot of sense if you're developing, but if you're on a production environment, there's quite a few things that you should change. Some actually have a drastic impact. See that in numbers in a bit. But it's a conceptual thing that caching obviously means that things might change over time, but that's not necessarily an assumption that is it's anyway true if you actually run in production, because if you have the system deployed, obviously that's not going to change unless you deploy again. So all the assumptions from the op cache checking if the file is still the correct version or if it got modified on the file system, they all don't make any sense for that kind of environment. So we should make sure that we are, first of all, before we even look into memory and any other things, is disable this checking of things. So validate timestamps, validate file upload, whatever kind of things, everything that you might need on a development machine, running tests, whatever kind of environment where you want to have certain information available, you don't need in production, so let's just get rid of it. The last thing is the most important for testing, particularly if you use PHP unit, because you are likely to still use one or two annotations in there. At least you should, because on some things, annotations make a lot of sense. If you throw them away with the safe comments being 0, then PHP unit is not able to run properly anymore because it doesn't find the information in the annotation because they are technically just comments, so they got removed. But for production code, usually that's not a problem, unless your code relies on comments in production, which they shouldn't because it should be all precompiled. So those are the things that you definitely should change. Then if you have a relatively large application, the default setting for files, as in how many files are actually supposed to be kept in the op cache, is comparatively small. If you have a large application, that's likely not to be enough. So you're going to have constant, stuff being dropped out and new stuff being added, and this is going to go in cycles. So you're actually wasting a lot of potential in the op cache. So make sure that this number is high enough, and this graphical representation that we just showed you might actually help you telling this is so and so many files that we have already, and this is how many files have been removed because of we're running out of space for that. And of course, having the correct memory setting. We have an arbitrary number here with 512. That's the megabytes, obviously. This is not just a recommendation, it's just a value that made sense for our testing environment, but obviously that's not far from being like the recommended value. It's just like a value that you have to figure out based on how many files you have and how big those files actually are.
Yeah. And one thing to keep in mind is that op cache, when it hit the maximum amount of files, will not throw away old ones, like you would expect from a cache maybe. It will just stop caching new files. And this is an interesting thing when you deploy to new directories on every deployment to be able to switch between versions, but you don't restart the PHP-FPM process, but you reload it, which generally is a good idea because you want to not have lost requests, then it will just add the whole application again in the op cache. And there are ways around that. We don't have it in the slide, but you can manually clear the cache. But there are other ways we can do it that we will see later, which have as a side effect, which solves the situation. Anyway, one small optimization you can also do on deploy, since the files will not change after you deployed them. We can
yes, they shouldn't.
Yeah, they shouldn't at least, yeah. We can preload the code into op cache, so basically warming op cache. So we won't have a slow first request that is maybe triggered by a user, which we don't want.
Yeah, and as you can, there are various ways to do a cache warming. Obviously, you could run just all kinds of weird requests to make sure that you potentially have requested every file or required every file at least once, which is relatively expensive. Or you create a static require list, which of course will load all the code of everything. Or you use the actual opcode API for that and use a tool to generate a list for that. And as it turns out, I at least like some time ago created a tool that could do this, which is originally intended to create autoloading files, but since it can use the list of class names for pretty much everything, I ended up writing like this small template. So if you add the warm parameter as in the W in the parameters, it will just generate a file with all the classes. They're going to be even sorted in a proper way, as in the things that you're needing first are going to be loaded first, even though that for op cache warming doesn't make any difference. But for static requires, that might. So with that, if you gently execute this on a command line, triggering that as into the FPM, so that's in that process pool available, then you have it in op cache.
Yeah, so that's op cache. There's a second topic which also technically doesn't really belong to FPM, but it's also related, and that's handling sessions. And we'll talk about sessions a couple of times later, I guess. Now, the first thing that we can do to optimize this is remove the garbage collection for sessions, which normally can happen every nth request based on the configuration.
And that's really expensive, particularly if you have the classic files save path setting on the file system, so everything is stored on the local disk. And if you have lots of traffic, you're going to have lots of sessions. So what PHP has to do is iterate over all the files and figure out if they are outdated, and if so, just throw them away. So that's a lot of I/O, and that's going to be expensive and make the unhappy request relatively slow.
So to not have like one unlucky user who triggers this and then has to wait longer than others, you could write a very simple script that just triggers this manually and execute this either as a separate request or as a cron job, various ways to do that. Although, I mean, this works around the problem that you have to remove files from the file system. Would be even nicer to not even have that problem. And by now, common solution for that is to use REDIS sessions.
Yeah, which basically means you're going to introduce REDIS as an application or as a service to use. And since there's a C extension for PHP to use, probably not anything new for everybody who's familiar with using REDIS in general, you can also configure it to be the session backend. So you just say the save handler is supposed to be REDIS and not files anymore. And then use the save path just pointed to the socket or the IP address with the TCP protocol and where to use it. And the last option that you can see in this path is obviously persistent equals 1. There are additional parameters that you can potentially pass, but this one is the most important. Particularly if you have the master process being run, there's no need to actually reconnect all the time. You can just make a persistent connection for that.
Yeah.
Will save most if you run on a TCP level, not on a socket, but still makes a difference.
Yeah. And with this, PHP doesn't have to care about collecting outdated sessions anymore because Redis will take care of that out of the box because the keys have TTLs. So we got that out of the way.
Yeah.
So yeah, we had a couple of smaller things that we could change now, and they always sound like, okay, is that really relevant? Does that make a big impact? And we made another set of benchmarks on a different application.
And on a different machine.
Different machine. So not really comparable to the first one, but the important bit is the relation between the different steps, right?
So the first thing is just to show that it makes a difference if you have Xdebug enabled. Not a big surprise, I presume. But if the default setup for development machines quite often is to have Xdebug in there, so if you then run stuff, obviously it's going to be slow. If you disable it, it's quite a bit faster. Disabling the access log writing is a bit faster, but not really much. Obviously, enabling opcache makes quite an impact again. Using persistent connections, not only for Redis, but also when talking to a database, makes quite an impact, particularly if you have static PM pools, so it's always a one-to-one relation. Then you can tune the opcache, like we showed, like making the file system checks off and actually setting the correct memory limits and file limits. Using Redis sessions makes it, again, faster. And if you disable garbage collection on top of that, it's actually really fast in comparison to where we started off, at least. And this is really just to show how different the numbers are, not necessarily the absolute values are important. This is just a small application that I created to do a simple MySQL query, select some values, and just draw a table in HTML, and then spit it out. So it's a really simple application, not really doing anything very complicated.
Yeah, but there's still a lot of potential in that. And so this now all covers optimizing like one FPM stack with one pool sitting there with some workers. But especially in production under high load, it may be a good idea to not only use one pool, but use multiple pools with one master process. Because not all requests that you receive in your application are equal. So you have some reading requests, you have writing requests, you will have some more expensive requests because maybe there's a file upload involved or something that takes a while to process. And PHP-FPM can manage multiple pools with one master process. The master process can basically listen on separate ports or sockets, and then based on which port or socket is requested, it hands requests to a certain configured pool. So here we have a different port number now, for example, and everything that comes in on that port is handed to a different pool that might have a completely different configuration. So a different set of workers, for example. With that, you can create pools that are optimized for certain use cases. And that can be particularly interesting. If you have a web application, you usually have a lot of reads and a less amount of writes. And most of the time, the reads are the ones that are mission critical because maybe you get traffic from Google or something and you want to serve it as fast as possible so users don't bounce. And with separating this and creating a separate pool that is optimized for the reading requests, it makes it much easier to scale for that.
Yeah, nothing much to add to it. It's just the stripped down configuration example. You can create as many pools as you feel like. They're just going to spawn like any other FPM process would spawn itself. You can have some configuration changes, like in this case, the memory limit. That can, of course, also be different per process. What you can't do is change extensions. So if it's not loaded in one, it's not going to be loaded in the other either. So that doesn't work, at least not that way. We're going to deal with that in a second. But it really makes it easier to actually determine what is considered a slow request, like you can see here with the slow log and the request slow log timeout. So assuming that this is a query type of thing, so this is something that's supposed to be fast, we can say, okay, everything that's taking more than 1 second is way over, so this is something we consider too slow. Also, we want to have it locked. On the other hand, if it's a backend thing or a post thing that we know that does some processing, obviously we don't want to have 1 second being locked as too slow because that doesn't make sense for that kind of application part. So we want to have a different configuration.
Yeah, so if this is a pool for like the web and mostly reading, then we could, for example, also have a separate pool for some backend UI that a shop manager uses to log into and change things. And first of all, there might be more expensive requests. We maybe don't care about slow requests at all, so we don't have a slow log. We have a lot less workers, so the other pool had 200. Here we only have 20 because we don't expect that many requests in parallel. And we have a much higher memory limit because, well, maybe there are processes that require a lot of memory, and that's maybe fine in this pool.
The reason why this memory setting is really important, even though it may not seem like it, is it makes things predictable. If you have a static set of processes and each has a hard memory limit, you can really calculate how many processes in parallel you can actually run as a maximum, because there is no chance, even if the application tries to get more memory, to actually allocate additional memory. So you can guarantee either it's crashing because the script dies because of being out of memory, or everything works as planned.
Yeah. And here's another kind of example, this time in an NGINX configuration, but it covers the same topic. So we also here have two different FPM pools being used. And here we separate by a request method. So we have a pool for GET requests, and we have a pool for POST requests, which you could also easily do. So yeah, top of the configuration, we have those two upstreams configured in NGINX. So there's basically one socket in this case for GET and one socket for POST. And then in the actual location, we forward the request to the upstream matching the request method. So yeah, it's basically this line here that then relates to the upstream that we configured. So now I could actually have a pool that is optimized for GET requests, and I could have one that's optimized for POST requests.
We do have some time left.
No pressure. Now, this already can do a lot for you, but as Arne already mentioned, there's limitations. So you cannot change all of the PHP configuration. You cannot change extensions which are being loaded or not loaded. And also, upcache, for example, is shared per master process, not per pool. So both pools will still use the same upcache. So to go even further,
it was one override.
I skipped one, and I can't go back for whatever reason. Well, it was basically the idea of having one pool per application version, so you could tie that to your deployment. So every time you deploy, you create a new pool, and that version will use that pool. But then you have the issues with the shared opcache, which might not be perfect, because then your opcache gets larger and larger, and at some point you will hit the limit. Yeah, and also we can't do something like this. If we have a pool that's optimized for reading, and that does not cover any backend tasks, maybe we don't need the image magic extension or something like that, because it's only used in particular use cases. So at least I can go forward. Yeah, so the next level would be to have separate FPM master processes, which you could still have on the same machine.
Yeah, or you just go on different machines, obviously.
Which probably would be nicer. This is a simple example for systemd.
Yeah, this is just, if you look at this pretty much copied the original systemd service definition for PHP-FPM, and I just renamed it to PHP-FPM 2, and just have a special configuration. That's the -c for the ini file and some other config file if you scroll over. So the pool configuration. And the no daemonize is just so that systemd can take over monitoring and not have PHP monitor itself. So this is just a different way of adding additional services. So you can easily start additional services and just add them to the systemd configuration. So this can be automated, relatively simple.
Yeah. So with this, you could have a completely different PHP ini file with a specific set of extensions loaded. Also, you wouldn't have the shared opcache issue anymore. So you could even probably automate that during deployment and use a separate FPM master process to have a fresh opcache and a fresh environment with fresh workers just for that version. Yep. Yeah, but sharing everything on one machine never is a good idea, right? So scaling is more than just increasing resources on the server, yep, but we also want to be able to scale over separate machines.
Yeah, and the cool thing is that all the optimizations we already did make that really easy, because we now have separate pools. We have REDIS as a session, so we don't have the dependency on the file system anymore. And we can simply have the web server spawn to or talk to various servers. So just increase the upstream pool that we already defined, which currently only had one entry. That's going to get just some more. And we can just have that split into individual instances. So with that, we can also scale on top of that. So it's up to you to decide if you have one big pool or just various smaller ones, whatever seems to make more sense. Having more smaller ones obviously helps in case one of them dies, that not everything is lost. But that's probably also depending a bit on your infrastructure and your requirements. So if you want to have more than one, then we, of course, have to deal with the session stuff in the middle. So that's easy with Redis because we just have all the systems communicate to it.
Yeah, and we have an NGINX example again, a very brief one. I mean, one thing to note here, of course, is that on the FPM machines, there's no web server running. We just don't need that because they just expose their port 9000 and the web server is just in front of that.
Yep. Yeah, so this is basically the same kind of thing we had before with the upstream pool where we just had the get and post separation. Now just a few more servers along with that and some more powerful options that NGINX provides for us. We can set, in this case, for example, how many maximum connections we're going to have to it at a given time. So in this case, limiting it to 10 for the first one. So this is going to be local socket. The other is going to be based on IP address and port numbers. The weight, obviously, is making this thing more important than the other. So it's more likely that this machine is going to get requests. Max fails and fail timeout, I think they are pretty much self-explanatory as well, saying that if we have 3 fails in a row, then this thing will be out of the loop for 30 seconds. We can mark a server as down, which seems to be a bit stupid to actually have it there and not just remove it, but it's pretty much the same way as commenting it out. But you're still going to see it in monitoring tools. And you can have a backup. The backup is not used unless some of the other machines is going to consider dead, and then it's going to ship that one out and replace it with the backup. So if you have more machines backup, this would be the same thing. So if more than one machine is down, then you're going to get the next backup included.
Yeah, and last thing to add here is when you split your servers across multiple machines and you have a shared session storage and probably some database sitting, it's always a good idea to introduce read slaves, depending on your infrastructure, of course, if that's possible. But for MySQL, for example, you could easily set up MySQL read slaves that are on, as close as possible to the FPM process.
Yeah, so much for optimizing PHP-FPM. Now let's do some more things that are still optimizing.
Yeah, so welcome to the bonus talk, optimizing PHP for production. Still, FPM is going to help us here. We already mentioned the slow log, which you can configure to catch slow requests, quite similar to the MySQL slow query log. So you can also configure that in your pool, as we showed earlier. And this is one example of how an entry in this log could look like. So it will tell you the pool name and the pool ID, or the process ID of the worker, sorry. And then you get kind of a stack trace of that slow request. And I mean, here we made it quite easy, right? There's a sleep in here to actually trigger this.
Which may actually be intentional, depending on what you're doing.
Yeah, OK. Yeah.
You laugh, but it's actually a true story. I guess everybody, I'm not going to make a commercial for it, but like this big hotel reservation platform that comes from the Netherlands, they, based on the story that I got told by one of the admins, introduced a sleep in their reservation final page for the very simple reason this site and the process was so quick that people ended up calling them. It was too fast, so they didn't believe they actually managed to do a booking. So they introduced a sleep in there to make the booking process seem slow, and by that, do something. And it, true enough, stopped people from calling.
I think you have to document that really well so that no new developer like all the time comes and says, hey, there's a sleep in here. This can't be right. Anyway, so what this will allow us is to look at slow requests in our application and to start optimizing the application itself. And I mean, the slowest thing we have is I/O. So what we want to reduce is the I/O we have in our application. And first thing that normally works quite well without doing too many changes is introducing persistent connections.
Yes, which seems like weird because there's always like, particularly if you look in just Google for persistent connections, you're going to get like, I don't know how many hits on people arguing in forums and Stack Overflow whether it's a good or bad idea. And granted, if you don't know what you're doing, it might be more problematic than actually doing any good. But if you have a static FPM setting, having that particular process reconnect every time is just a waste of time. So if you know that your application ends in a reasonable fashion and not just going to hog this process forever, this makes a lot of sense. And this makes quite an impact, as you might have seen or remember from like the benchmark results. Having the persistent connections actually just gave another additional boost because all this reconnecting overhead handshake, particularly if you have like TCP connection with TLS enabled and everything, all that handshake stuff just goes away because it's just done once and then you're there.
Yeah, and as Arne mentioned here, the static setup of the workers really comes into play because if you have a dynamic setup, it would respawn new workers and they would have to reconnect again. So this really helps. We have 3 examples, I think. This is like the PDO thing, how to make a connection persistent. So you add an additional parameter in the constructor. Yep. Looks a bit different for MySQLi.
Yeah, obviously somebody realized, oops, we forgot persistent connections, so we just add that into the host name somehow. So we actually have to put a P colon in front of it. Why ever that is the syntax, okay?
Yeah, and since we use REDIS for sessions, it definitely also makes sense to use persistent connection here. So there's, instead of calling the connect method, you call the pconnect method. That's pretty much it.
Yep. So now we optimized everything without actually changing much in our actual software. Let's see if we can optimize more things by simply not doing work. That sounds awesome, right? We just avoid the work. And one of the cool things that you can do is, particularly if you have NGINX included, is simply have NGINX do the work for you. I mean, NGINX as a web server, well, actually it's a TCP server that just happens to speak HTTP. But as that particular thing is designed to actually send data around, why would we do that in PHP and in userland level? So our approach would be to not have PHP send data that it doesn't have to send. So that means if you either upload files or download files, quite many people write like, okay, you have to check whether you have access permissions and everything. So then you pass through file get contents, echo, whatever kind of thing. So but just everything goes through PHP, which if that's a large file, it's going to take a lot of time. And of course, will make the PHP process stay busy for no apparent reason. So one of the cool things that NGINX can do is use the XACL redirect or acceleration redirect, which is just another header that you can send in your PHP request and tell NGINX, you know what, I'm not going to send any data, but you can find the file that's supposed to be sent at this path. So that just needs to be a path that NGINX has access to, and then you can go for it. Which is nice, but that's only half of the story, obviously. If you upload stuff, you still have the same kind of things to do. So NGINX can also help you there because it can simply remove all the upload stuff from the request and just put it as a file somewhere else. So PHP-FPM just gets a path where that file is. So if that is somehow available on the shared file system, for example, you can simply go from there and have the NGINX, well, take the heavy lifting of all the data that gets in there anyhow and just don't forward it to PHP. So the PHP-FPM process is not that busy for that long, which helps a lot. That's a funny configuration. I'm just rushing a bit because we're almost running out of time. So this is, obviously, the upload should only work for post requests because otherwise you cannot send a file, or put might be as well, but let's just stay with post for this example. And you say, OK, we're going to have our uploads being stored in the given directory. Say how much we actually want to buffer. This is just like internal, how much can be fetched at one go, and what the biggest file would potentially be. And we're just going to forward everything except for the request body and simply set an additional header. In this case, the example is X file to show where the actual file is, which is just going to be a path in like the temp directory and some temporary file name. So with that, we have a file pointer, as in, well, not a file, actually a file name that we can use without actually having to deal on the PHP level with actually requesting the file and actually having all the temp variables PHP does. So that's cool, but we can do better still. So let's go one level further. And I think that's like pretty much the upcoming buzz term is CQRS. And since we already started with getting separated things from reading and writing, as in get and post separation. Actually doing this on the application level may be the actual thing that gets you even further. We have a lot of people talking like, yeah, we have to optimize caching and add additional things, but if you change the concept of saying, okay, we're not going to actually do any work on the read request, we can make a lot of things even farther. Because having it in the fastest possible way is not doing any work. So if you have it almost static, that means it's going to be the fastest thing that could possibly work. So what I did with our small sample application that I used for the higher number benchmark things on a smaller machine, I simply replaced the SQL query that fetched all the data and then rendered the HTML from it. Replaced that by a REDIS call that fetches a pre-rendered HTML which contained exactly the same information. And just benchmarking that gives you the final numbers of the day, and it's still quite a bit faster again. So
for larger applications, the impact is usually much higher.
Yes.
Because you eliminate all the need for querying data, doing joins, whatever, template rendering, and you just deliver already rendered HTML, which works in many cases, especially on web applications. It's really easy to do because the data only changes when there's a write operation. So I don't know, new blog post got added, then you regenerate the HTML, and on reading, you just deliver that rendered HTML.
Yep.
Sounds like caching, but it's not.
It's really, really cool. And just as a small hint how awesome that is, they use continuous integration, obviously. And if they test their performance and if the normal read request on their website is slower than 100 milliseconds, that's considered a fail.
Yeah, so then the build fails, no deployment. Yeah.
Because obviously somebody broke stuff, because that's really, really fast in comparison to doing everything on request.
Yeah. Well, of course, that got us a bit carried away from the overall FPM topic, right? But eventually you'll end up there because there's a huge potential in optimizing applications, and you can do a lot of things with FPM that will already help you without changing the application. But as soon as you reach the limits there, then you have to dive into that.
Yeah. Avoiding work is obviously going to be faster than trying to make it faster work.
Yeah.
Okay.
Yeah, we are right on time, I guess. So I'm afraid there won't be time for questions right now, but
unless they say we have, but I don't think so. Okay, well then.
That's all right. We'll stick around at the social. So
if you have any questions, feel free either to find us during the social or drop us a mail or contact us on Twitter, whatever makes most sense to you. Thanks for being here, and I hope it was a fun session.
Thank you very much.